Okay, you sent me this document for me to explain. You said I should explain all of this. This is STAAD results. You want me to explain to you. You want me to explain, these results from your analysis. Okay, so I'll explain it now, and I'll do that very quickly. So I believe you performed the analysis on a structure, a reinforced concrete design, and STAAD provided the design result for flexure. That is to say, the design result against, flexural stresses induced by movement. And then STAAD provided the result against shear. So let me explain what you see on this table. Now this is telling you that at a height of 35 millimeters from the bottom of your concrete cross-section, you require a reinforcement size of 3 number of 20 millimeter diameter reinforcement. Okay, it's saying that you require this reinforcement from a start point of 0.478 meters to an end point of 4.522 meters. Look at your total length of your beam is 5 meters. Okay, so it says that at a height of 35 millimeters from the bottom of your concrete cross section. What does it mean? Okay, look at assuming this is your concrete cross section. So what STAAD is telling you that from the bottom of this concrete cross section here to the center line of this cross section to the center line of the tensile reinforcement, it's telling you that you need 3 numbers of 20 millimeter reinforcement. Then it's saying on the compressive zone you need also 4 numbers of 8 millimeter reinforcement. So it means that this section was heavily loaded and is automatically doubly reinforced, so you need compressive reinforcements to add to the compressive strength of the concrete. So you also need reinforcement on the compression zone. That was it is stating. So it's also saying at a height of 188 millimeters from the bottom of your, so it's giving you the levels where you have your reinforcement. The reinforcements are arranged in levels. You have a level here, you might have another level there, and all that. So STAAD is telling you the levels of reinforcement arrangement. From these distances are measured from the bottom of your concrete cross section. So if you see a level of 188 millimeters, automatically means that it's somewhere around here. How the STAAD gets that distance. If you look at it, I think your cross section is 230 by 230 millimeters. Let's do some calculation. Your cross section is 230 by 230 millimeters. The cover, this is a reinforced concrete section based on your fire resistance. I believe your cover is 25 millimeters. If you subtract 25 from 230, you have 205. Your links is 8 millimeters. If you subtract 8 millimeters from 205, you have 197. Okay. Now the size of your reinforcement is 20 millimeters. So if you then subtract 10 from 20, that's to say to the centroid of your reinforcement, you have 187. So that's where 188 was obtained by STAAD. So it is telling you that at a height of 188 from the bottom of here to the centroid of your reinforcement, okay, you have this number of reinforcement. You need 3 T20 from a distance of 0 to 772 millimeters. Okay, it tells you, do you need anchorage at the start point? Yes. Do you need anchorage at the end point? No. So say, do you need to anchor your reinforcement? Yes. Do you need to anchor reinforcement? No. In the same way, your shear reinforcement is telling you that from end 1 to a distance of 2.83. So end 1 is, note that this is a beam of length 5 meters. So it's saying from the left end, that's from the start end, to a distance of 0.83 meters. This is the maximum shear force you're having. This is the corresponding load case providing this maximum shear force. This is the size of your stirrup. How many do you require? It requires 17. The spacing is 130 millimeters. Okay, so your spacing is 130 millimeters. So that was the saying you require. Then from this distance, 2.916 to the end, you require this size of reinforcement. This is the spacing of reinforcement required. If you look very carefully, you can see there's a distance between this and this. That's to say 2.916 minus 2.083. Okay, so a distance of about 833 millimeters is saying that you do not require any reinforcement. So most possibly, the concrete cross-section has significant shear capacity to resist the shear force. That's why it has done the design based on the design requirements of the cross-section. So I believe that this has answered your question or responded to the concerns you've had. Thank you very much.